All right, guys, welcome to week one of quarter four. We're going to go ahead and start taking a look at our Algebra 2 textbook, Chapter 1, Section 1. Okay. I made the Algebra 2 textbook available to all of you using the Realize Reader, so you can already go in there and feel free to look around, read ahead, or make sure that you're understanding what it is I'm going over. This chapter and section starts to look at what are called functions. You guys might remember these from Algebra 1. Okay. But just to make sure we understand clearly what a function is, a function is a special type of relation. And relations are simply input-output machines, right? So here you can have a machine, right? You got a conveyor belt over here. You drop your input, right? Goes in here. And then it comes out the other side. All right, conveyor belt, there's our output. Okay. Now, typically when we talk about this, right, the function, there's a couple different ways we can label it. You guys are used to y, but you're going to see that I'm going to start using f of x, right, or g of x or h of x, something like that to denote our function. And typically our inputs are going to be x. So we drop an x on the input conveyor belt, and then what comes out is y. So that's our output. Now what makes a relation special, such that we call it a function, is it has a unique output for every input. So function, right, has a unique output for each input. Another way to say that is the machine is predictable. If you tell me what you're going to put in and you define the function, I know exactly what you're going to get out because you can only get one output per any input. Okay? So that's kind of what a function is. All right? It's all we really need to focus on for right there. All right? Now, we've defined a function, right? And what they usually look like is maybe we have a function that says f of x equals 3x minus 4, right? And you guys are used to seeing this. This is a linear function from Algebra 1, right? We know it's got a y-intercept. We know it's got a slope, right? This is y equals mx plus b form. But we could have another function, right? We could have something like, hey, h of x is equal to x squared minus 4x plus 2. Now, with function notation, using the f of x and the h of x, we can go ahead and actually evaluate for a specific input, right? So here, if I were to write, hey, what is f of 2, right? Read that f of 2. This tells me, hey, I want 2 to be the input into the f of x machine, right? So here, I'm going to go to my function, and everywhere I see an x, I'm going to replace it with 2 because this is my input, right? So this will be 3 times 2 minus 4, right? And then I'll just simplify this, right? So f of 2, 3 times 2 is 6, minus 4 is 2. So f of 2 is equal to 2. Now we can write our solution to this as an ordered pair. That'll be a point like 2, which is my input, followed by 2, which happens to also be my output. All right. Now just to show you another example, right? We could also go ahead and evaluate for what h of 2 is going to be, right? So here we're going to do h. Let's do something different. Let's do h of 3, just to make it more interesting, right? So h of 3, I'm going to go ahead. Everywhere I see 3 in my h of x function, I'm going to put a 3 in. So everywhere I see an x, I'm going to put a 3 in because that's my input, right? So here, I'm going to go ahead and put in 3 squared minus 4 times 3 plus 2. And I'll go ahead and I'll simplify the right-hand side. What you'll notice is every time I substitute, I use parentheses, right? So here this says 3 squared, which is 9. 4 times 3 is 12, right? And then 9 minus 12 is negative 3, plus 2 is negative 1. So h of 3 equals negative 1. So I can write that as an ordered pair, 3, comma, negative 1. When I plug 3 into the h machine, I'll get negative 1 out. So there's just a recap of function notation. And again, that's all stuff that you should have learned in Algebra 1. Okay? Following along with this, there's some points of interest that we want to know, right? Which are called the x and y intercepts. Okay. So an x and y intercept, this is essentially where a function touches the x line, the x-axis, or the y-axis on a graph. But I like to use a different definition, one that relates back to this idea of a function. And so here an x-intercept is the value of x that makes y equal 0. So the value of x that makes y equal 0. So in other words, what input, right, will give me an output of 0? Every function will have exactly, can have multiple x-intercepts. There can be multiple x-intercepts on a function, okay? Now y-intercepts are a little bit different. A y-intercept is simply the value of y when we let x equal 0. So when x equals 0. So here we go ahead and we dictate the input. Now there should only be one y-intercept if it is a function, right? Because each input should have a unique output. That means here, if I put in 0, I should only get one output. Okay, so that's what makes it a function. So again, if we go back to our first function, right, f of x is defined as 3x minus 4, right? I can also go ahead and take a look and say, hey, well, what is the x and y intercepts for these, right? So let's go ahead and find the x-intercept to start. So the x-intercept, right, remember that is going to be an ordered pair, right? So my ordered pair, I know I want the output to be 0. So what I'm going to do is I'm going to go ahead here and let f of x equal 0. So I'm going to put 0 equals 3x minus 4. I'm going to see what number goes ahead and makes that equal 0. So if I add 4 to the other side, right, I end up with 4 equals 3x, and then I divide each side by 3. And I can see that x equals 4/3. So what that tells me is that my x-intercept is 4/3. Now be careful here. When you're writing x-intercepts, you should write them as ordered pairs. So here my x-intercept 4, 3, 0. Now if I want to go ahead and find my y-intercept, that's even easier, right? So for my y-intercept, right, I know my input is going to be 0, and I want to see what my output is going to be. So if I go to my function, I'm going to have f of 0 equals 3 times 0 minus 4. Well, 3 times 0 just goes away, and I end up with f of 0 equals negative 4. And we already knew that, right? Because y equals mx plus b, we know that this is b. Okay? So again, just a recap of some things that we're already familiar with, our x-intercepts and our y-intercepts. All right? Any questions there? All right, so the next thing we're going to talk about with relation to functions are going to be domain and range, right? So domain and range. Now again, if we're talking about functions as being input-output machines, domains are just all the numbers that we can put into a function, right? So all possible inputs for a function. In other words, it's kind of all possible x values. Okay. And then range, right, conversely, is just this idea of all the outputs. So range is all possible outputs for a function. Okay. In other words, it's all the possible y values. Okay. Now, when we talk about these things, we're going to find that there's two notations that we can use. All right. So we're going to jump over and we're going to take a look at a graph. Okay. So here, just to go over our coordinate plane, right? this right here, vertical axis, represents my y-axis. Right here, this is my y-axis. Okay? And then here, we go ahead horizontally. This is my x-axis. Now again, we can represent a function lots of different ways, but if we go ahead and take a look at this one right here, all right, I'm going to make kind of a weird function. Right, so a solid line there, right, where it goes up and over 2, right? We get a pen that writes a little better, right? Up and over 2. Oh, there we go, right? And then maybe here it starts to drop back down. Okay. And then maybe from here does kind of a parabolic shape. Okay. And I'm going to end it with an open circle. Okay. So this is what my function looks like, right? And this is crazy. But if I look at this function, I can go ahead, I can start looking at inputs and outputs, right? So here on my x-axis, right, I know if I put -1 in as my input, I can go up and I can read this point, right, as being 3 for my output, right? So this point right here is the point -1, 3. So you can see this represents a function. There's an input, -1, there's an output of 3, okay? Now when I look at this, and I'm talking about domain and range here, I want to look at all the possible values that I could put into this function, right? Because we can see here, if we go back to like -5, is the function defined? If I go up or down, will I be able to figure out what my output's going to be? Well, no, it's not, right? So what I have to do is I have to figure out which numbers can I plug in for x, okay? Now, the easiest way to write this is using inequalities, right? Now, what I like to do is I like to go ahead and take my function and I squish it down to the x-axis, right? So I'm going to squish it down to the x-axis. So I can see right here that this circle, right, is closed. And I can see that it's defined for all these points in here, right, until I get to this open circle, right? So now I can see that this green line represents my domain. Okay, so there's my domain. So the first way we can express our domain is using what's called interval notation, okay? Interval notation is pretty easy, right? We essentially pick up the first number and the last number, right? So if I look here, the first number all the way to the left is going to be -3, okay? So I know that my domain starts at -3. And then finally here, my last number, right, is 1, 2, 3, 4, 5. So it goes from -3 to 5, okay? Now you'll notice this looks like an ordered pair, but it's not, right? This is my domain. So I'm going to put a D in front, right, like this. Now here's the thing. This is a closed circle. That means that -3 is a possible input. I can put -3 in. When a number can be put in, we go ahead and we use a bracket like this. That tells me that -3 is included, okay? But you'll notice over here the 5 is not included, right? Because it's an open circle. So that means I can go all the way up to 5, but not 5. So I can go to 4.999999999, but I can't go to 5. Because I can't go to 5 and it's an open circle, I'm going to go ahead here and use a parenthesis. So there's my domain. I know that it goes from -3 to 5, and it includes -3, but it excludes 5. Okay? Now we can do something similar when talking about the range, right? So we want to go ahead and take a look at the range here. Right? I'm now just going to go ahead and squish it side to side and see how much of my y-axis it's covering, right? So if I go ahead here and I squish this down, we already saw -1, 3. It already goes all the way up to 3, right? And it includes 3, so that's a closed circle. And it looks to me like it comes down here and it touches right here at -2. So that looks like a closed circle, right? So it includes both of these. So if I go ahead here, right, this vertical line here represents my range. All right, just by squishing it down to the axis, I can now very easily read that, right? So for my range, right, I know that my range goes as low as -2. So So always want to list the smallest number first. And it goes up to 1, 2, 3. Okay? And since both of these are included, I know that both of these are going to get brackets. So this is what's called interval notation. So when I ask you for intervals, we can see here our domain is going to be -3, 5, and our range is going to be -2, 3. These are all the possible inputs. These are all the possible outputs. Okay. Now there is another notation that we use. Okay. The other notation is what's called set notation. Right. Now with set notation, we're going to use one of these squiggles to open a set. Right. So this is just set notation. This lets me know I'm talking about the set. And here, to denote that it's the domain, we're going to say it's the set of X such that, right? And this time we're going to use a compound inequality. So we're going to put -3, right, X, and 5. And we're going to close our set. Now here, I list them -3 on the left and 5 on the right because -3 is the minimum, 5 is the maximum. So I'm going to go ahead and put my inequalities here. Well, I know that X will be between -3 and 5. Now, because it includes -3, I'm going to put or equal to here, but it does not include 5, so that one does not get an or equal to. So I read this as the set of X such that X is between -3 and 5, including -3, but not 5. And then if we go ahead and follow that same notation for our range will be the set of Y such that, right? And here we'll go -2 less than or equal to Y less than or equal to 3. Okay? So we have two notations here, right? Up top we've got our interval notation, and on the bottom we have our set notation. Okay, so try to get used to those two notations. All right? Now in the last example, I went ahead and gave you kind of this weird function we'd never seen before, but we can actually take a look at a function that we're familiar with, right? We went ahead and we studied in quarter 3 quadratics, parabolas, right? So let's take a look at something like y equals x squared plus 2, right? This is a simple quadratic, right? So if I go ahead here, I can graph this quadratic, right? Here's my vertical axis. Here's my horizontal axis. And I can generate a list of points for this, or you can just take my word for it, right? I know here it's going to go through this point, and I know if I go over 2, I'll go up 1, 2, 3, 4, right? So this point. So there's kind of a general shape of my parabola, right? So I know it looks like this, right? And here it's going to have an arrow, and there it's going to have an arrow. Now, what do those arrows mean? Well, that tells me that it extends infinitely in that direction, okay? So we're going to take a look at our domain and our range, right? Now, because these arrows extend infinitely, if I were to go ahead and squish the graph down, right, it keeps going, but if I squish it down to the x-axis, how much of the x-axis is it going to cover? It's going to cover the whole x-axis, right? It's going to keep extending infinitely, forever, okay? So because it covers the entire x-axis, the way we would write this is we would say the domain extends from -infinity to positive infinity. Now, when you're dealing with infinity, positive or negative, right, we're going to go ahead here and we always use a parenthesis with infinity, right? So the domain is going to be here, all the real numbers, -infinity to positive infinity, okay? Now, if I want to go ahead and write that as a set, right, I would say it's a set of all x such that x is an element of real numbers. And that's it. So this is x such that x is an element of real numbers. Okay, kind of a weird thing, comes up from time to time. Now if I go ahead and take a look at my range, now my range bottoms out, right? There's a minimum here, right? I can see it only goes as low as this. And again, if I squish it horizontally, it's only going to be the part above this, right? But it still extends infinitely upwards. So when I write my range is going to go ahead and it's going to go from, this is 2, which is the lowest number, all the way up infinitely. So it goes from 2 to infinity. Now it includes 2, right? So I'm going to go ahead and give that one a bracket. and infinity always gets a parenthesis. And now to go ahead and write that as an interval, oh, I'm sorry, not as an interval, that was an interval. To write it as a set, it would be the set of all y such that, and here we simply have to write y is greater than or equal to 2. Okay? So there's an example where our function maybe has some arrowheads at the end.